In this quick tutorial using Cursor AI, we'll show you how to perform more precise refactorings with CodeScene's MCP server and give agents an explicit, measurable goal. We'll start by creating a refactoring plan and business case. In this first part, the AI invokes the MCP server and the different prompts. Objective feedback makes the biggest difference when refactoring. A detailed CodeHealth review, focusing on concrete maintainability issues, allows the agent to formulate a structured plan rather than guessing improvements. The business case prompt invokes our ROI calculation, using a statistical model and industry benchmarks to translate improved CodeHealth scores into business impact. That means increased development speed, fewer defects, and lower maintenance costs. This makes it easier to justify refactoring investments to stakeholders. So what is the business case of this refactoring? We see that raising the score from 8.38 to 9.1 on this particular file will give us a speed improvement between 10 to 16% and a defect reduction from 19 to 24%. The CodeHealth assessment has now been completed. Many legacy functions are simply too large and complex for reliable AI work, leading to higher error rates, excessive token usage, and fragile changes. Large legacy functions often require a preparation step. Breaking them into smaller, cohesive units improves modularity and makes subsequent refactorings far more reliable. The AI provides a step-by-step guide with small refactoring iterations. Our goal is a CodeHealth score of 10, the magic number at which code becomes AI-friendly, and the risk of AI-induced defects is about 60% lower than with the current CodeHealth. Next, we invoke CodeScene ACE, which restructures complex functions into smaller, more cohesive units and refactors the code one iteration at a time, with each step improving the CodeHealth. ACE has now completed its refactoring process. We went from a CodeHealth score of 8.38 to an optimal score of 10. Remember, 10.0 represents AI-friendly code, where the risk of AI-induced defects is 60% lower than with the code's original health.